Hi, kids! Today we will learn symmetrical figures, asymmetrical figures, and line of symmetry. So let's get started. Here is an image of a heart. Can you fold it exactly halfway so that its two halves are exactly similar, or one half completely covers the other half? Let's try. Here we are folding it. Yeah, it completely covers the other half. And when you can fold a shape in half and one half exactly covers the other half, we can say that the shape is symmetrical. And the fold line is the line of symmetry. So this shape is a symmetrical shape. And this line of fold that divides the shape into two similar halves is the line of symmetry. Now, let's try this with another figure. Here we have an image. Let's try to fold it and see if it is a symmetrical figure or not. Here we are folding it. Yes, if we fold this image here, it completely covers the other half. So it's a symmetrical image. And this line of fold is its line of symmetry. Now, let's try the same with another figure. Here is a rectangle. Let's fold this rectangle halfway. If we fold it here, it does not work. Example, one half does not cover the other half. So let's try another way. Let's fold it this way. Yeah, if we fold it here, it works. That is, one half is completely covering the other half. So we got to know that this figure is symmetrical, and this line of fold is the line of symmetry. Now, kids, you have a fair idea. What are symmetrical figures and what is line of symmetry? Now, let's see if
Okay, let's get down to business. So today we're going to talk about shapes of graphs, and we got a concept here. You already watched the video, and you learned, or at least you got the idea of what is a symmetry and what is um, the line of symmetry. Okay, let's read it. The symmetry and graph of functions. So we're talking about functions, so it's important to discuss this. The graph of some function exhibit a key feature called symmetry. And what is symmetry? Someone told me symmetry is if you got a shape, as you remember the video, and you got like a heart. Okay, let me see if I can make a heart. Okay, and you cut this out, guys. You cut this out, and then you fold it. You're gonna get the same shape, right? You put them together,
yeah.
you fold it, and there is no leftover part. Then we're gonna talk the line of symmetry, guys. Is that line, the imaginary lines that you can fold it? It's like the half of the shape. That is the line of symmetry. Let's take a look at this function. At this function, this is a function like. Take a look, guys. This is a function. You got one, two intercept, and in this, guys, take a look that if you fold this part, you fold it and you put it here, guys, you're gonna get the same shape, right? That is, guys, this is a this function got a symmetry, and this the half of that, guys, is called the line of symmetry. And this one is another one. Take a look that this is a different shape, like a W. If you cut this out, guys, and you fold this to this side, you see that you're gonna have the same shape. Okay, this is the line of symmetry. This is what we're going to discuss about. Okay, this is in page 187, 187, 187. And what we are asked here is to determine whether each function has a line of symmetry. If it does have it, and we have to explain what is it. Okay, let's have a look at this one. Do you think, guys, that this shape, this like the letter B, as in Victor, this is a symmetry?
No.
This line?
No, mister.
No.
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 Why not?
Because if we
Because when
Because
we
they
divide
don't
it
have the
by
same
two,
shape.
they don't have the same shape.
Okay, maybe you have to notice that this continues, guys. This continues. Maybe it didn't they I mean the author books didn't include it because of the space, but this continues, guys. Now if we fold it, do you think we have the same shape if we
Yes.
fold the particular
Yes.
one? Yes, right, we got it. Okay, yes, we're gonna say yes. Okay, we got a line of symmetry. Okay, oh my gosh, that yes is awful. Okay, yes. Okay, yes, it has a line of symmetry. But I want you to tell me what is the line of symmetry. I want you to color that line of symmetry. What is the line of symmetry? What is the center or like the half where we can fold this down?
Mister,
Uh, when
you
it's
are
a zero.
you will send this class.
Yes, I will. Okay, yes, I will. Okay, this line, guys, this is the line of symmetry, right?
Yes.
Okay, I
Yes.
want you to identify that and tell me, Mr. Line of symmetry. Okay, this is the line of symmetry. And can someone tell me what value for x is that line of symmetry, guys? This is 0, this is 1, this is 2. What value is that? This is x. What value for x is that one?
I
This
Mister,
is
think
since
0,
yesterday I don't
1,
find my
2. It is negative?
negative two, I think. Negative
Mhm.
one.
negative
Negative
one.
1. Yes, it's negative
Negative
1.
Negative
one.
one.
X equals to negative 1. Take a look. This is 0. This is 1, 2, 3. Okay, 0, negative 1. Negative 2 is this one, negative 1. Okay, x is equals to negative 1. Okay, you don't need to copy this. Just to tell me if this is, if you can fold this and get that. What about the number 2, guys? Do you think this is it has a
Yes.
line of
Yes.
symmetry?
Yes, mister.
Yes.
Yes, you can fold
Yes.
this in different ways as you want. You can fold it like this. You can fold this part, this first part. You can fold this and put it here, and you're gonna get the same. Okay, yes. Okay, it has a line. It is a symmetry. It has a line of symmetry. What about the number 3? Do you think this one, guys, is a symmetrical shape? This
No.
one?
No.
No.
Hmm. I remind you that this
I guess
continues,
Ah,
guys.
we
yes,
continue.
yes,
So
yes.
This continues. Maybe because of the space, you don't have that. Okay. Can we got a half here likes and we can we fold that? Yes, right. The
Yes.
center is like this point, like something like this. Hmm.
Yes, mister.
That could be the line of symmetry. Okay, you can say line of symmetry.
Mister, in the second way, we don't put the line of symmetry.
No,
Yes.
because that
We,
particular we don't. Okay, we can use a function, but we're gonna discuss about later. You just tell me that if it has a line of symmetry or not. Just yes,
Mister, it's
because
necessary to put the like x equal in the
no, no,
over.
no, 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 not like that. If you can, I just want you to guys to have I mean, a vague idea about this.
So
So
we just have to put yes or no in the line of
yeah, uh-huh.
symmetry.
Okay.
Correct, correct. And tell me, this is the line of symmetry. It is like
Okay.
in the last class that you told me, you used to tell me this is positive, this is negative. If you want to
Okay.
include the values, it's up to you. Okay,
Okay.
what is the line of symmetry approximately? If you can do it, you do it. Okay, what is the line? Okay, 0, 1,
Two,
2, 3.
Three.
Between
three,
2 and 3. Between 2 and 3 is
2.5, 2.5.
2.5.
2.5.
That's
Five.
correct. 2.5. That is the line of symmetry
Mister,
for this
so it's
function.
not necessary to put
It's not
x equal
necessary.
to.
Correct.
Oh, okay.
Not necessary. Not necessary. If you want to add it, that's okay. What about the number 4? Do you think we can fold these guys and get the same shape? Can
Yes.
we make the
Yes.
same mash?
No. No, I don't know.
At what
No.
point? At
No.
what point can you mash then?
Yes, no. Like wait.
Mhm.
In
You
the
that you
no,
got the book,
mister.
try to
in
fold
the
it.
center, I No, think. Mister,
Okay.
no.
If you
Yes,
fold it
because if
at this
it would
point,
be vertical, yes.
I think if you
Uh,
fold it at this point, you're gonna get something like this then.
Yes.
Yo, okay, this one, guys, no, it
uh,
doesn't have, no, it hasn't. It has not a line of symmetry. Okay, let's see if we got more. Oh no, just this. Now we're gonna talk about something pretty straightforward. We're gonna talk about a stream of graph of function. And what is that, guys? We can have, guys, when graphing, especially nonlinear equations, we can have function that can be either increasing means, guys, something that is going up, increasing, growing up, and we can have, okay, the graph goes up, and decreasing where the graph goes down, okay, increasing and something that is decreasing. I repeat, increasing, going up, and something that is decreasing is going, something that is going down, getting down. Okay, when we viewed that from left to right. Okay, but what is that, guys? We got some concept here that I want you to know. This point, guys, exactly where the graph is really high or really down, these points are called extrema. Okay, let's take a look at this one. A point A, can you see? Okay, this is the point A. Take a look at this point, this graph. This point A, guys, is called the minimum relative minimum. Why? Because it is the, I mean, the lowest point that you can see here, right? Can you see that this is getting down, getting down, getting down, and at this point you stop, and then it goes increasing. Okay, this point, guys, that is down is called the relative minimum, because no other point has a lesser y coordinate. Is what I was telling you. There is no other point that is lesser than it is, I mean, down this or below this point. In a relative maximum, guys, what is the relative maximum in this graph?
the one that decreased.
A until B.
Okay, the one that
The
is
one
here,
that
like
decreased.
in the top of the mountain. This is
Yes.
like in the top of the mountain. That is the relative maximum. And the one that is down, like in the hill at the top, I mean, at the beginning of the mountain, that is called the relative minimum. Relative minimum, minimum means mínimo, bajo, pequeño. Relative maximum, maximum means maximum, the biggest one, the greatest one. And this is how we're going to determine this. What else do we have here? We can have, guys, something else that is whether the graph is increasing or decreasing or both. Let's have a look at this one. All right, we have to determine if this function is increasing or increasing and decreasing, both. It could be both. Let's have a look. We said that something, a graph is increasing, guys, if the graph is going what? Increasing goes up or down?
Up.
Increasing.
Up.
It's going up.
Up.
Okay, it's going up. Can someone tell me? Just put it here, guys. Let's see. Intuitively, is this function increasing or decreasing?
Decreasing.
Decreasing.
Yes, it's like if you're here, guys, and you slide yourself down, okay, you're gonna fall down. This is what?
Decreasing.
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 Okay, decreasing. Okay, decreasing. Correct. This is decreasing. Okay, let's take a look at this one. Okay, take a look. This is one of you guys. You put yourself here and then you let yourself
That's
down.
increasing.
You
Increasing.
decreasing.
Increasing.
But what happens here,
In-
guys?
Increasing. It's increasing.
increasing.
Okay, it's decreasing in this point and then increasing. Okay, this is
It's
both.
both.
Okay, we're gonna say both instead of writing the increasing and decreasing. Both, it's both, because at this point this is decreasing, but at this point this is increasing, just like that. Let's have a look at this one. Okay, you gotta
Both.
tell me
Yes, both.
Both.
for decreasing, oh, and then getting up again. This is both or
Both.
decreasing. Both.
Both.
Okay,
Both.
because one part of the function, guys, this part of the function is, let's see, guys, if we can identify that. Okay, just to have a better idea, we're gonna say that this part is decreasing, and this part,
Decreasing.
guys, is what?
Increasing.
Increasing.
You can do that just to notice. Okay, then it's
It is
both
not necessary,
decreasing.
mister.
I would like, by the
Ah,
way, I
okay.
would like to do this just to put this decreasing, increasing, just to have a better idea. What about this one? What is this?
Both.
Okay, this
The
part, okay, this part of the function, this part of the function is increasing, increasing. Okay, all of this is increasing. And then suddenly out of the blue, the graph goes down. This part is,
decreasing.
then is both. Okay, is both. Okay, I forgot to put this one. Okay, as well. Okay, this is guys decreasing here, decreasing, decreasing, and then it goes up, increasing. Then it's both. Okay. Now let's go to this one. Let's go to this part. We are going to determine the extrema of x, f of x. Then we need to identify each point as relative maximum or relative minimum. Again, piece of cake, guys. You need to tell me, guys, the relative maximum, guys, is the highest point that you can see in the graph. Can someone tell me what is the highest point that you can see in this graph?
Letter B.
Okay, excellent. That letter B, guys, this point is the relative maximum.
Maximum.
Maximum, okay? Relative maximum. I'm gonna put this just RM, guys, because I don't want to be zooming in and out. But you write that word, relative maximum. Okay, can you identify what is the relative minimum of this graph? What is the lowest point?
Letter D.
D, correct. Okay, you go there. This is the top of the mountain, and then okay, this is the letter D. Okay, the letter D. That is the relative.
Minimum.
I'm gonna put a M lowercase to denote the minimum and maximum with a capital letter. Relative. Yes, you can write it better, guys. You got the books right, right there. Okay, it's because I don't have it. I don't want to be zooming in. Okay, let's see the number 12, 13, and 14. Again, this one. What is the relative maximum or the relative minimum? Okay, let's see the graph. What is the relative maximum? What is the biggest value?
B. B.
This B is the relative maximum. Okay, that is supposed to be an M. And what is the relative minimum? What is the lowest values? What is the S for value?
A and C. A and
Oh,
C.
okay,
Both.
this and this. Yeah, both of them. There are the relative minimum. That's correct. What about the number 13? What is the biggest value, guys? On the top. Oh, that's correct. Yes, yes, yes. That is this D, guys, which is the biggest values. That is the relative maximum. And what is the relative minimum?
B.
B. Excellent, excellent. That is the relative minimum. Correct. I repeat, you can write this, a relative minimum. So I'm just using this letter just to denote that. Okay, this one, which is the highest point, guys, at this graph?
B.
Oh, again, this is easy, right? B, this is a relative maximum. And what is the
And
lowest point?
D.
D. Okay, we got this D. Which is, the F is a maximum, but it's not the relative. That is just an extrema. Because we are just identifying the relative maximum, which is the biggest one. It is like the top notch, which is the biggest one. This is extrema, but this is not the relative maximum. The relative maximum is this one. Now we're going to talk about another concept, and this is called the end behavior of graph of functions. And what is that? The end behavior, guys, just describes the value of a function at the positive and negative extremes in its domain. Oh, what is that? So domain is what? Can someone tell me what is domain?
Dominar, I think.
The bird domain is dominar, yeah, but in mathematics, domain. Domain and range is x, the values for x. This this is x, domain. Okay, what is the end behavior, guys? We only need to determine, guys, what is happening. Take a look at this. Take a look at this graph. Graph. Okay, if you move, guys, to the right of x, the domain. Okay, as you move right. Okay, as you move to the right, what is happening with the graph, guys? What is happening with this graph if you're moving to the right? The graph is decreasing, it is falling down, right? Excellent. Okay, that's what we got. If x increases, if this value for x goes to the right, increases, then y goes down. Okay, y decreases. Let's see the opposite. What if we go to the left? As you move to the left of x, what happened with the graph, guys?
It's going to increase.
It's going to increase. Okay, when x decreases, y increases. What is that? Let's have a look at more examples.
But why?
All right, let's determine the end behavior of these graphs. Okay, again, you only need to see. Okay, I'm going to zoom in this time. Okay, I'm going to zoom in just a little bit here. Okay, if x, guys, this is what you're gonna see. Take a look. If you go, guys, if x goes to the right, what happened with the function? Take a look. If you go to the right, what
It's
happened
going
with
to
the function?
increase. It's going to
Okay,
increase.
you're gonna say x increases. When x increases, what happened with y?
It's
Y
going
goes
to
what?
increase.
Increase as well. Okay, y increases. It sounds like in Spanish, increases. Okay, when x
That
goes to the
too.
right,
That too
y
increases.
increases, right? Okay, what happened if you go to the left? Okay, if you move to the left, guys, like this, let me see. If you move to the left, what? Okay, x, when x decreases, right? This is your fault. Okay, then if x decreases, I mean, if x goes to the left, what happened with the function? What
It
happened with the
increases.
function?
Increase.
It's going up, okay? The function y, okay, then you're gonna say y increases,
Increase.
increases as well. As you can see, guys, in this case, this function, if you move to the right, the function goes up. If you move to the left, the function goes up. The same.
Yes.
Okay, let's go to the number 18 and let's see what is going to be the behavior for this particular one. Okay, again, let's move to the right. Okay, let's see what happened when you move to the right. If x increases, what happened with y?
Y decrease.
Decreases.
Okay, take a look. If you move to the right, this is getting down. Okay, it's going to be getting down. Okay, y decreases. Y decreases. Okay, let's do the opposite idea. Okay, let's move now to the left. Okay, if you're moving to the left, that means that x is decreasing. When
And
x
Y increase.
decreases, what happened with y if you move to the left, guys? What happened with y?
Decrease.
Decreases too. Okay, y decreases. Okay, again, this is the idea. If you move to the right, oh, the function goes down. If you move to the left, the function goes down. That is decreasing, increasing.